So before I get started, a quick intro about myself. I'm Sai Srirampur and you can call me Sai. I'm an early engineer at Citus Data and now part of the Microsoft family. And I'm really excited about this acquisition because I would get to see more and more use cases. The reason I joined Citus is to make it so that developers never have to worry about scaling their database. An interesting fun fact about myself is I recently got married. So very excited to see how that adventure goes. So before we get into the demo and the session, I just wanted to bring up some pain points which we hear from customers in the real-time analytics world. So the first which we hear is they are on a single node PostgreSQL database. They have already beefed up to the largest instance, but then still they are running into performance issues. They have also operational issues like their vacuums are not running in a performant way, etc., etc. So this is number one. The second is they have two separate stores for analytics workloads as well as transactional workloads, and they're running into hassles to maintain both of these stores, and they want to have a single system of record which handles both analytics as well as transactional workloads. The third is something related to pre-aggregation and roll-up pipelines, where they have a pipeline which does pre-aggregations. That pipeline is either inside the database or it is exterior to the database, but then it's not that stable. It lags and never catches up. So this is one pain point which we also hear. And to solve all these three pain points, you have Postgres and Citus at your rescue. And why Postgres? Postgres because it's a very rich, robust, open source database with which is good for both transactional as well as analytics workloads. It has a very rich ecosystem with extensions like HLL, TopN, Citus. It has rich geospatial features thanks to Postgres. It also has very rich SQL features like CTEs, window functions, JSONB, full text search, etc., etc. The second, why Citus? Citus because it transforms Postgres into a distributed database. So what Citus does is Citus lets you shard your data across multiple Postgres databases, but for the end user, it looks and feels like a single node PostgreSQL database. So as you're sharding data across multiple Postgres databases, you are inherently scaling all the resources, namely memory, compute, as well as disk. Along with this, Citus also enables you to parallelize your queries across multiple workers, by which you get like linear performance benefits. Last but not the least, Citus is an extension to Postgres. So you get all the rich features which Postgres has, like JSONB, HLL, similar to the slide which was present before. One thing I'll also talk about is the partitioning feature which Postgres 11 has. The latest Postgres should work with Citus as well out of the box. You might be thinking on how you could use Citus. You can use Citus currently in three ways. The first is a database as a service offering, which is called Citus Cloud. With Citus Cloud, you get all the enterprise features, but we also take care of the database in the sense that we make sure that the cluster is always up and running. We make sure that the lights of the database are always on. So you get features like backups, high availability, logging, monitoring, and all of this is automated for you. The second is enterprise software, where you buy the software licenses from us and deploy it on your own hardware. The third is our open source offering. This is where you can download our packages, use our Docker repository, or check out the GitHub repo, etc. So here is our GitHub repo. Feel free to go ahead and lend a star. It's all open source, just search Citus Data, GitHub, and you would get to this page. So before we get into the actual hands-on stuff, I wanted to introduce a couple of concepts which are important to understand before we go into the demo. The first is the Citus architecture. In the Citus architecture, you have something called as the coordinator node, and you have multiple worker nodes. The coordinator node and worker nodes are nothing but simple plain PostgreSQL databases. And for the end user, all of this architecture looks and feels like a single node Postgres database. The coordinator node is the node which orchestrates your queries to the right worker nodes. The worker nodes are the nodes where the actual data exists. That's where the actual computation happens. So from the end user point of view, what you do is you connect to Citus, very similar to Postgres, and say, let's create a table. Say here we create the campaigns table, right? Once you do that, Citus gives you a simple API through which you can shard or like make the table distributed. So let's say, let's shard the campaigns table on a column, which is called the shard key, on the company ID here. So once I run that like API or the SQL function, Citus creates shards, and shards are nothing but simple plain PostgreSQL tables, which hold a set of your data. So if you see here, the green ones on the workers are shards. So shards are nothing but simple plain PostgreSQL tables, which hold a set of your data. And here, as I'm sharding campaigns on the company ID, each shard would hold a set of your company. So it's very similar to consistent hashing, if that makes sense. So if there is a query for a single company, Citus routes that query to the right worker node and executes the query. But then if the query is for multiple companies, similar to what you're seeing here, an average which spans multiple like companies, Citus parallelizes this query across multiple workers and gives you the result. So as you're parallelizing your query, Citus gives you good performance. As I said before, the two main reasons you get good performance is number one, parallelism, and number two, under the covers, you have shards, which are much smaller. You have smaller indexes, by which in general, your resource utilization, the index hit rates, the cache hit rates are much better. Along with this, you also get the ability of horizontally scaling out, in the sense that you can keep adding smaller nodes to your cluster and rebalance your data all in an online way. So whilst the rebalance process, you don't need to take any downtime with respect to reads and writes. So this is one. The second is this webinar features roll-up workloads. So just wanted to explain what a roll-up is. Typically in analytics workloads, what we see is dashboards generate very similar kind of queries, doing similar aggregates and spanning similar data sets. In that scenario, instead of having queries recompute data every time on the fly, you could pre-compute data and store those aggregates in tables, and your dashboards can optimally query these aggregated tables for better performance. And those tables are roll-up tables. So typically in a roll-up table, you have multiple columns. The first column is the period. So this is the time column. This could be hour, this could be minute, this could be like, say, a second, based on like what is the granularity of the roll-up. The second type of columns are dimension columns. So here you see country, customer, site. These are the columns which you want to query on. So these are like the columns which have the where clause filters, if that makes sense. The third type of columns are the aggregates, where you have sums, counts, say count distincts, etc. So these roll-up tables can be further filtered and aggregated to generate charts. That's what happens with these dashboard queries, where you query this roll-up table, which is much smaller, and generate graphs on a certain granularity, as you see here, right? So what are the benefits of roll-ups? The benefits are, number one, as roll-up tables are much smaller, from a performance perspective, they are queries are like simple lookups on the aggregate tables. The second is they avoid expensive repeated computation. This is something which I told before. Third is roll-ups can be further aggregated. So what we see with customers is they have, say, hourly roll-up tables. They create daily roll-up tables from the hourly tables. And then if they have workload which is on a daily basis, then they use these like much smaller tables, the daily tables, for querying purposes. The fourth is roll-ups are compact and hence can be kept over a longer period. So you could have roll-up tables holding like multiple years of data as well. Also wanted to introduce what HLL is. HLL is an approximation sketch algorithm, and it helps you estimate count distinct or cardinality of a given data set. So count distinct is a big problem, especially when you have large data sets. HLL helps you solve this problem in a very optimal fashion. Remember that it's finally an approximation algorithm, and you can configure it to make it less accurate or more accurate, etc. Postgres has a very cool extension called HLL, and this is maintained by Citus itself. And what it does is it introduces a HLL data type, which helps you store distinct values of a particular column. And the biggest advantage of this is, especially in roll-up workloads, one thing to keep in mind is count distinct is not a commutative operation. So you cannot add two count distincts to get the final count distinct. Hence, It's very hard to build count distinct in your rollup pipeline. But then the HLL extension introduces this HLL data type, which makes you do rollups and pre-aggregations even for count distinct aggregates, if that makes sense. So let's get into the demo now. So what I did was I spun up a Citus cloud cluster, a 4-node database cluster, similar to what you see here. There are 4 worker nodes, each of them 60 gigabytes of memory. And then I spun up a regular PostgreSQL database on a single node. And as a part of this demo, we'll run multiple queries. One is loading data, creating indexes, some simple selects and aggregates, which you see in analytics workloads, and also run rollup queries, both on the 4-node Citus cluster as well as the single node PostgreSQL database. And we'll do some performance benchmarks on how a distributed environment compares to a single node database environment. So let's get to the demo. So as you see here, I have 2 windows. The first window is where I would be running queries on the 4-node distributed database. The second window is where I would run queries on the single node Postgres environment. So what I did was I created 3 tables on both the databases. The events table, the users table, and the user metrics table. The events table captures all the events you create on GitHub. If you do a pull request, if you do a commit, all that is captured in the events table. Users holds metadata related to the user. So if a user signs up, the username, the password, the avatar, all of that is captured in the users table. The third is the rollup table, user metrics, where I have hourly aggregates on the user ID dimension. So it's, if you see, this is the schema for the user metrics table. I have user ID, R, which are both the dimensions, and I have 2 aggregates. One is number of commits for the user grouped on the R. Next is number of distinct repositories. This is where like I have the HLL data structure, which stores the distinct repositories and grouped on user and R, right? So this is the schema which I'd use for both the setups. And another thing to note is to save some time, before I started the demo, I loaded data into both the tables, the events and users table on both the databases. And if you observe, the copy command on the distributed table takes around 39 seconds, but then the copy command on the single node PostgreSQL table takes around 92 seconds. So you already see around 3x performance benefits on copy and these bulk operations on distributed setup. And the main reason is because all these operational commands like copy or vacuum or create index fan out in parallel across all the shards, by which you see like good performance gains on a distributed setup than compared to a single node setup. So let's get started with running some queries. So the first query I have for you is a simple count query, which counts the number of events on both the tables. So this query took around 45 milliseconds on the distributed table. And let's run the same query on the single node PostgreSQL table. And it's still running. So let's wait for this to finish. It took around 11 seconds to complete this query, but I think it took so long because the data was in cold cache. Let's run it again so that it's more representative. And if you observe, it took 203 milliseconds. So there is a performance improvement of close to 5x on the distributed table, which is spread across 4 nodes, then compared to the single node PostgreSQL table. And the reason this happens is because what Citus does for these aggregate queries is it does a map reduce. So it runs the count in parallel across the 32 shards, gets those 32 counts, and then sums it up on the coordinator node. And that's what you see here. So it uses the real-time executor. The task count is 32. There are 32 threads hitting the 32 shards. And then this is just one task present. And then if you see here, it does a sequential scan on the events table. And then here under the covers, this is just one shard. Okay. So one thing which I forgot to mention, which I want to bring it up now, is in regards to the schema. One thing which I did in Citus is I sharded these tables out. So as I said before, Citus gives you a simple API called create distributed table. So I sharded events, users, and user metrics on the user ID column. So this may basically partitions the table and creates like by default 32 shards across the 4 worker nodes. So each worker node would have 8 shards of the events table, 8 shards of the users table, and 8 shards of the user metrics table. So for count, we saw close to 4x performance improvement. And now let's run a second query. So here I'll create an index on the event type column. So this is a simple plain P3 index. So let's see how long this takes. So on the distributed table, it took around 295 milliseconds. Let's run it on the single node PostgreSQL table as well. And looks like it took around 1.5 seconds. So you see a performance improvement of close to 5x on the distributed table then compared to the single node PostgreSQL table. And the reason is again similar to what I said before, that you have the create index command runs in parallel across the 32 shards. And generally we listen from customers that in production, these create index commands, these vacuum commands, or even the create index concurrently commands are much more performant than before. So let's run a second index creation command, which is on the payload column. Here I'm creating a GIN index. And if you observe here, payload is a JSONB column. So this ties into Citus being an extension, hence it supports the latest data types like JSONB, HLL, etc. So let's run this, and let's run the same on the single node PostgreSQL table as well. So let's wait for this to finish, and looks like on the distributed table, it took around 9 seconds for the create index operation. And on the single node PostgreSQL table, it's still running. So let's wait for this to finish. And in the meantime, I'll bring up a poll on how many of you have used JSONB before, or like have experience with it. So yeah. Looks like the create index is still running. So what about the poll? Yeah.
It looks like about 63% of the folks have used JSONB before and 37% have not.
Awesome, awesome. So that's a good number. And so JSONB is a data type which Postgres has, and it helps you store unstructured data in Postgres. And generally customers use it for storing logs or documents. And it has very good indexing capabilities as well, because you can create these inverted indexes using GIN parameter in Postgres, by which you can even search through the JSONB object. So it's a pretty cool data type, and please feel free to go ahead and check that out. So yeah. So this is still running. So let's see how long this takes. And remember that this particular index command is on the single node PostgreSQL table. Should get done pretty soon. I remember that when I ran this before, it was around 2 minutes. So let's see. Awesome. So looks like the create index is done. And as I said, it took around 2 minutes on the single node PostgreSQL table, and on Citus, the distributed table, it took 9 seconds. So there is close to around 12x performance improvement on the distributed setup, distributed 4-node setup, when compared to the single node setup. So let's go ahead and start running some queries, which are typical in analytics workload. So here I have a query to find the top 10 users who created the most number of repositories. So this is where I'm joining the events and users on the user ID column, and I'm getting an aggregate on the grouped on the login column. So let's go ahead and run this query. And also remember that I'm querying the payload JSONB column, right? So let's run this on Citus. It took around 90 milliseconds. And on single node Postgres, it took 376 milliseconds. So you see a performance improvement of close to 4.5x on the distributed setup then compared to single node PostgreSQL setup. And the reason this happens is, let's look at the explain plan. So what Citus does is Citus runs this aggregate in parallel across the shards and then gets those aggregates and then aggregates them on the coordinator node. So all this logic of, okay, if it's a sum, let me do a sum followed by a sum. If it's an average, let me do a sum followed by a division is in the Citus extension. So that's what you see here. So you see that there are 32 tasks. It uses the real-time executor. And one interesting thing here is also the join is pushed down. Because under the covers, as I sharded the users and the events on the user ID column, Citus makes sure that these two tables are collocated. And what I mean by collocated is shards of the users and shards of the events table representing the same set of users are on the same node. So if I do join operations, Citus straight pushes them down across the collocated shards and then performs the join operation. So this is what you see here. It does the hash join, and then it also pushes the aggregate here. And one interesting thing to notice here is it also uses a bitmap index scan, and it scans the payload index which we created. And remember that this index is just on one of the shards. So under the covers, this index is much smaller than compared to what you have in the single node Postgres environment. Awesome. So next, let's run queries related to the rollup workloads. And this is the interesting part. So Postgres gives you a simple construct called insert into select, in which you can aggregate the raw table, the events table here, and then dump results into the rollup table, and here the user metrics table. So let's run this query, and on both the single node Postgres table as well as Citus. It's running and looks like it took around 253 milliseconds on Citus. And let's run the same query on the single node PostgreSQL table. And it took around 3 seconds on the single node PostgreSQL environment. So there is a performance improvement of close to 11x on the distributed environment then compared to the single node environment. And the reason this happens is because this particular rollup or the pre-aggregation operation is parallelized across multiple nodes. So if you run an explain plan, you'll see the same, right? So if you remember, I sharded both the user metrics, the aggregate table, as well as the raw table, the events table on the user ID parameter. So hence this rollup operation is pushed down to the worker nodes, runs in parallel and across the collocated shards. And this is the query plan, if you see here. So in general, you see like very good performance benefits even for these in database rollups on Citus than compared to single node PostgreSQL environment. And in the future, I'll talk about some other benefits which you get if you speed up your rollups. So that is coming. This is more the technical part. So cool. So once you rolled up data, typically what you do is you'd have your dashboard query the rollup tables, right? So let's go ahead and query the user metrics table for a particular user ID. So here I'm querying the the information for user ID 1341245. And then here, if you observe, I'm also querying the HLL column, which is present in user metrics. So HLL gives you some cool APIs like HLL cardinality and some, which let you get the count distinct. Here, count distinct for the number of repositories. So let's go ahead and run this on both the distributed environment. So it looks like it took around 2 milliseconds. And here it took around 15 milliseconds. So you see a performance improvement of close to 7x on the distributed database than compared to the single node Postgres database. And the reason is because if you look at the explain plan, this explain plan is slightly different. So it uses something called as the router executor. And what does the router executor do is, as and when it sees that, okay, my query has a filter on a particular user ID, as the table is sharded on the user ID, Citus routes this query to the right shard on the right worker node and executes the query. So there is just one task here, if you see here. And then this is the query plan on that particular worker executing on that particular shard. So the reason you get good performance benefits is because under the covers, you have much smaller shards, right, than compared to the large single node PostgreSQL table present. So cool. So to summarize all these queries which we ran, let me bring up a sheet, and hopefully Teresa filled this sheet, and yeah, awesome. So you see that on an average, all the queries are running close to 8.4x faster on the 4-node distributed setup than compared to the single node Postgres setup. And the reason this happens is because Citus lets you parallelize your queries across multiple machines, as we saw both for rollup queries, the select queries, the operational queries like copy, vacuum, create index, etc. Second is it also lets you horizontally scale your database in the sense that you can keep adding smaller nodes to your cluster and rebalance and move your data all in an online way. So you don't need to take any downtime with respect to reads and writes. The third is it also guarantees freshness of the data in the sense that we have a number of customers who do like real-time inserts, real-time updates on the database, and then they have these dashboards which are querying fresh data coming in real time, and they also use rollups. So it really depends on the use case. It also gives you good concurrency because under the cover, Citus is across Postgres. So we have seen Postgres to be very good at concurrency. So we have customers with close to 500,000 concurrent users hitting the database. Last but not the least, you get the benefits of both transactional as well as analytics workloads in a single system of record. So zooming into rollups, so we ran the rollup queries. If you remember, we ran the insert into select and also queried the aggregate tables, and we saw a very good performance benefit on Citus then compared to single node Postgres. And the reason is, number one, fast rollups are because of the parallelism. Under the covers, your queries are parallelized. Hence, you don't run into that pain point of, okay, your rollup pipeline is lagging or it never catches up. The second feature, the second ability it gives you is it lets you increase the granularity of a period. And what I mean here is we have a number of customers doing rollups, and before they talk to us, they used to have rollup tables which were say at a granularity of a day or an hour. But then with Citus, as you get that performance, they made it more granular. They have like rollup tables which are up to a minute as well. So in the database, and then their product features improved because they could show more insights to their customers. The third is, as Citus is finally a distributed database which lets you shard across multiple nodes, you could store longer periods of data. So we have seen customers who were initially storing like say an year of data, but then have increased to like multiple years and they increase their retention because of Citus. And last but not the least, you can complement your rollup pipelines with extensions which Citus provides. First is the HLL extension for count distinct approximations. We also have the TOPN extension, and this is for top n records approximation. So this is for frequency approximations. And pgcron, which is an extension which lets you schedule jobs at the database layer. So you can actually schedule these rollups using pgcron, and it makes it very easy for you. You don't need to have a separate app which runs these rollups. Instead, you just push it to the database layer. And last but not the least, there is also the pgpartman extension, which lets you implement partitioning at the database layer. So this is for time series data. So you can either partition your rollup tables or you can partition your raw tables. And the advantage is expiry or even constant exclusion that you can, if you have a where clause filter on time, you just like go to the suitable partition. So even partitioning with pgpartman would work with Citus, and we have seen customers complement it with rollup pipelines. So awesome. This is where I would talk about three of our customers who are in the real-time analytics domain. First is Heap Analytics. Heap Analytics is one of our largest deployments. The use case is user segmentation and behavior analytics use case, where you can get insights into website usage and customer usage on your website. So they have a very large Citus cluster. They have close to around 60 to 80 nodes, and they have close to a petabyte of data on the Citus cluster. And they have 700 billion events, now I think close to 1 trillion. And then they have 34 terabytes of memory across a 17-node Citus cluster. So please feel free to go ahead and check out the story on this particular URL. The second is Algolia. So this is something which I added recently to this webinar series. So Algolia uses Citus to power their analytics dashboard, and Algolia is a search as a service company. So you can power your search using Algolia, and these guys use Citus to power their analytics dashboards for search data. So they pump data into Citus in regards to searches, and they do roll-ups at the database layer, and they use the extension called TopN, and their queries are mostly like, okay, get me the top 10 searches, say grouped on the country for this particular customer, etc. So using TopN, they get the ability to perform pre-aggregation and roll-up jobs for even these kind of frequency and top-N queries. And they have 5 to 10 billion rows ingested per day, and 95% of their queries are less than 800 milliseconds. So feel free to go ahead and check out their story. This is also a very interesting talk which the engineer gave on this particular use case. So feel free to go ahead and check it out. The third is Microsoft. So Microsoft uses Citus for their internal Windows telemetry use case. And this is also, again, a roll-up use case in which they have raw tables, and then they have these periodic jobs which aggregates data into these aggregate tables, and then they have dashboards which runs queries across these aggregate tables. And one interesting keyword which the engineer used was something called as incremental map reduce. So roll-up workloads are incremental map reduce at the database layer. So they also have a very large deployment of Citus, close to 700 cores, 4 terabytes of memory, and 100 terabytes of data across multiple Citus nodes. So there is a very interesting talk given by the engineer, and there is a YouTube video as well. So feel free to go ahead and check it out. As you know, Citus got recently acquired by Microsoft, and we are very excited about this. And one thing I'd say is we are very actively working on having Citus on Azure, and our team is working hard to make it so that this particular offering is the best offering out there with respect to security, manageability, performance, etc. So this was the webinar I wanted to do, and finally I wanted to give a tip that if you have real-time analytics workloads, please use Postgres and Citus and test it out. And I'm sure that you would see good performance benefits, and you would get the rich Postgres feature set as well. So yeah, here I have a couple of links. First is the open source link where you can download the extension. Next is the link to our managed service offering where you can create dev accounts which are smaller and they're not that expensive. So you could spin up a dev cluster and test out Citus. And last but not the least, the link to our Slack channel. Our Slack channel has close to now, I think, around 2,000 users. And there are very interesting topics, not just about Citus, it's also about Postgres. So you could join, and I'm sure that you would there would be good technical information shared across the board.
Thank you so much again, everyone.
Have a good one, guys. Bye-bye.
Have a good Tuesday.